Two parts are less than a, two parts are less than a. We start out with a function. Definition of a function. Do you remember the definition of a function? Could you say without reading it off the board? Because you do know that you're going to have to do this for your test. You need to know the definition of a function, a relation in which every element of the domain corresponds to exactly one element of the range. We memorized it last week and then it just flew from our brains, right? So we understand if we don't come back to it, then we just forget it. So you got all sorts of other classes you got to memorize stuff for. So we got to think of this whole function deal and figure it out. So I want you to look at that definition, and I want you to take 30 seconds to try to memorize it when we recite it together. So make sure you know it. So we have these two important parts of that definition of a function. We have this domain, and we have this range. So what do we think of domain? Generally, the domain is what we refer to as the inputs, or the independent variables. And often, those are the x values. Okay, so we choose to use x and y. It doesn't have to be that way, but many times it is. The range would be the outputs. They're the dependent variable. They depend on what x is. So if you plug in something for x, that will determine y. Okay. All right. The first skill that we want to be able to do, you're going to be able to do this on your test, is be able to identify the domain and the range of the function. I want to be clear that these directions are actually incorrect because not all of these are functions. Can you tell me which ones are not functions? This one is not a function. Why? Doesn't pass the vertical line test. And 4, because there is a vertical line. So the direction should say identify the domain and range of the following relations. Some of them are functions, some of them are not. So how do we determine the domain? I will show you. I like to grab vertical and horizontal lines. For determining domain, I'm focusing on x. So I grab an x equals equation. X equals is a vertical line. Okay? Does the graph ever have values here? How about here? How about here? How about here? How about here? No, but everywhere then to the side of -4, it starts to pick up values, correct? Until I get to -1. Then I do not have values, and I do from 1 to 4. So the way that we express that is -4 to 1, or -1 with a bracket union 1 to 4. For the range, I drag a horizontal line. For the horizontal line, I start down here. There are no values down here. I eventually come on up here and I cross right there and I cross right here. So what's different about the range compared to the domain? There's just two specific numbers. In order to show specific numbers, I use roster notation. So the two specific numbers of the range are 2 and 5. We move it on over to the next one. I grab a vertical line. Is the graph going to cross this vertical line eventually? Yes. And so the domain goes from what to what? Yep, -infinity to 1. The range, I grab a horizontal line. You can see that it will cross down here eventually. It's got an arrow set in a downward direction and off to the left. Okay, so I'm going from -infinity up to what value? 4. Oh, did a really bad job, Mr. Gantz. How about for this guy? Domain? Yeah, how about range? Yeah. Domain negative infinity to infinity, and range negative infinity to infinity. I want you on your own to see if you can do the next three examples, 4, 5, and 6. After you get one of them, please come and put your result on the board. 3 different people put your result on the board so we can see how you did it, okay? And then we will get you into your first assignment. Go. These are correct, but the last one, a lot of people don't put -1. What do they put instead that's a mistake? They put -3. Do you understand why? They look at where the point happens. So often we look at like the vertex or the corner of something, and we think that that plays a role. But that doesn't actually play a role at all in this problem. Good job. You ready to start your assignment? Part, okay? So this is new for you. We want to look at domain by simply looking at the function. You know what the graph of x squared looks like. So suppose I didn't give you the graph and I just said, what's the domain of x squared? How would you think about that? How would you answer it? And you would be saying to yourself, what kind of x values can I plug in and still get an output? So think of all the numbers on the number line, okay? All the numbers on the number line. Are there any numbers that you can't square? You can square anything, right? And that's why the domain is all real numbers. And if you're ever wondering about that, you can start to just check numbers. Okay, Jack, give me a number. 12 square, you get 144. That's a point on the graph. It's a location. Hannah, give me a negative number. -2 square, you get 4. Square 0, you get 0. These are all points on the graph. If you plug a number in, you get an output, then it's part of the domain. However, look at the next one. Which number do you think causes a problem? So what x value can I not plug in? What number on the number line can I not plug in? 3, because if you do plug in 3, you get 6 divided by 0, and that does not work out. That's not a number that you can plot. So therefore, the domain is all values not equal to 3. The way we write that in interval notation is -infinity to 3 union with 3 to infinity. So if you see a rational function, meaning a function that's in a fraction form, you have to be careful if the denominator could ever be equal to 0. What does that graph look like? It's very interesting. It looks like this. It has what we call a vertical and a horizontal asymptote. One happens at the y value of 2, one happens at the x value of 3. And the graph looks something like this. Actually, might be flipped in other quadrants, but that's good enough for what we're talking about at this point. And you can see now graphically, as you move left to right, you can see how the number 3 gets eliminated, correct? Yeah. So that's the domain. The last one is a square root. Can you think of a value for x that I can plug in that I will get an output for? What is the number I can plug in for x? 12. 12 plus 4 is 16. Square root is 4. Give me another number. 60. Plug in 60. 60 plus 4 is 64. Square of that is 8. How about 1? Can I plug in 1? You can square root of 5. There's nothing wrong with 1 square root of 5. You can plot that. How about 0, Jack says? Sure, 0, 2. How about -4? If you plug in -4, what do you get? 0. What if you plug in -5? Oh, you're shaking your head. Can't have square root of a negative, can you? So it turns out if you plug in anything that's less than -4, it's not going to work out. X must be greater or equal to -4, or from -4 to infinity. The graph actually looks like this. So what's different about this is that I'm going to give you a bunch of functions, and you want to be able to determine for me what its domain is without being able to see the graph. Your first kind are polynomials, like x squared. Polynomials don't have restrictions. Y equals x squared has a domain of all real numbers, -infinity to infinity. Or y is equal to 2x minus 6. It's just a line. It has a domain of negative infinity to infinity. Or y equals x to the 5th plus x squared minus 2. All polynomials have domain negative infinity to infinity. But rational functions like this, you can't divide by 0. So therefore, rational functions that have restrictions to the domain, say 4 over x minus 1. What could x not be in that situation? 1. Or say 3 over x squared minus 9. What can x not be in that situation? 3 or negative 3. You got two situations there. But sometimes people make a mistake. They say, if I see a fraction, then I know that I'm going to have to leave some values out. That's not true. 1 over x squared plus 1. Why is that not a problem? Why does that have no restrictions to the domain? Squaring it makes it positive, and then adding 1 will make it positive. Do you agree that this bottom could never be less than 1? The bottom could never be 0. It's impossible. Radicals, square root of x. Going to have some restrictions there. Square root of 3 minus x. Fourth root of x plus 1. And soon people say, well, if you have a radical, then you got to make sure you can't have any negative values underneath. Well, that's not true at all. Cubed root of x minus 3. You can't take a square root of a negative, but can you take the cube root of a negative? You can. So cube roots don't cause any problem. But then people say, well, so if you've got even roots, that's where you've got the issue. Well, not all the time. Look at this one. The square root of x squared plus 1. You're never going to get the square root of a negative, are you? Never. So therefore, there's no problems there. So let's try it. Some of these are going to go super quick. Some are going to be a little bit more involved. See if you can tell me what the domain is. First one, square root of x plus 2. Is there a problem with taking square roots? Can't take square root of a negative. So x plus 2 must be greater than or equal to 0. So x is greater than or equal to negative 2. Negative 2 to infinity. That's the domain. Next one is just a polynomial. Domain of a polynomial. All real numbers. Next was a rational function. Can't divide by? Can't divide by 0. What number would give you 0? 4. So x can't be 4. You could write it in interval notation like this, or you could just write x can't be 4. Either one would be acceptable. This 12. Are cubed roots a problem? No. $13, I got a rational function. Can't divide by 0. So what would give me 0 in the denominator? Yeah, x can't be 0 or 5. Fourth roots. Do fourth roots cause problems? Yeah, they can. 7 minus x must be greater than or equal to 0. You got to see where that's positive. So negative x is greater or equal to negative 7. Divide by negative 1, x is less or equal to 7. So negative infinity to 7. There's my domain. What about 15? Yeah, it's just polynomial. It's a line. Looks like this. What's the domain of this? Yeah, all real numbers. Next one looks like a rational function, but it's not really a rational function, is it? It's just 1/5 x squared minus 1/5. What shape does that make? What's the domain of a parabola? All real numbers, negative infinity to infinity. Uh-oh, 17. Surely there's an issue there. I've got a fraction, right? Why? Okay, so x squared plus 1 cannot be 0. So therefore, all real numbers. Oh, these look really challenging. The first one's tough. The next two are actually really easy. I'll show you. Square root, that's an issue, isn't it? 3 plus 2x minus x squared must be greater than or equal to 0. Oh, we've got an inequality with a quadratic. You remember, you got two ways of solving that. You can either make a table or look at the graph. I'm going to multiply through by -1. I get x squared minus 2x minus 3 is less than or equal to 0. So that factors to x minus 3 times x plus 1 less than or equal to 0. So where does it cross the x-axis? 3 and -1. So are we wondering where this graph is above the x-axis, or are we wondering where the graph is below the x-axis? We're wondering where it's below the x-axis. Where is it below the x-axis? So what that means is if you plug in any number between -1 and 3, it's going to produce a positive value for you. So you can take the square root of it. But if you plug in any number outside of -1 and 3, it's going to produce a negative value, and you can't take the square root of it. Second one's the same thing. X squared plus 2, greater or equal to 0. But that doesn't factor, does it? I wish I knew what the graph looked like. Parabola shifted up 2 units. The question is, where is it above the x-axis? All the time. Next one, I got another stinking square root. -3 minus x squared, greater or equal to 0. Shoot, doesn't factor. I wish I knew what the graph looked like. Parabola, upside down, down 3 units. The question is, where is it above the x-axis? Never. There is no values for the domain. It's the empty set. Nothing available to plug in ever. Take 20 seconds, talk to a friend about number 21 to see if you can come up with anything intelligent about the domain. Go. Good. I heard some really intelligent things. Tell me what you were saying. You're right. X can't be 3. What else? X has to be greater or equal to -2. Aren't those conflicting statements? Because isn't 3 greater or equal to -2? So if you just think about what that would look like graphically, X is greater than or equal to -2. But X can't be 3. So that's the type of graph that we want to express. So we go -2 to 3, union with 3 to infinity. What do you think about that, Ashton? You like that, huh? Thank you for sharing your interest and your love and concern for mathematics. Okay. Next was just slightly more challenging. Think it through. Give you 30 seconds here. Talk about with a friend. Go. All right, we're going to see what you got. What'd you think about x greater or equal to -4? Sounds good to me. Why didn't you do anything about the bottom? It's cubed root, so everything's good to go, right? Except you can't divide by 0, and what number would give you 0 at the bottom? So x can't be 2. See how we eliminated 2 from the issue? You saw a cubed root. You thought, oh, everything's okay. Well, but you can't divide by 0, and 2 will give you 0. So therefore, we're going to go greater or equal to -4. So -4 to 2. And then we got to exclude 2. So 2 to infinity, excluding that way. Man, you guys are smart. You did the best of all the classes. Congratulations. I don't. No. No. So I'll tell you what you guys did. When I said you guys talked amongst each other, you actually did. The other classes didn't talk today. They took a nap. And then the other thing is you guys actually came and put the answers up on the board here when we were doing this guy right here. So it took a while, right? But it's better when you're moving and better when I'm not. Okay? All right, I'll give you the second part of your assignment. This assignment is what I call a get to it when I get to it assignment. You guys put this and you file it away. And then what happens is the day before a test, you got no idea what's going on. And you say to yourself, man, I wish I would have looked at this. So what did I do? I put it on the final exam. So the stuff we just did right now, you're going to be asked questions on the final exam about that. We have to figure it out. We'll do some checkpoints over the next couple days. I'll get your assignment to you. You got 5 minutes. We got to